Okay, so in this part of the video, just to continue on here, we looked at preferences, and we said we basically finished it by saying that the goal is to be in the highest indifference curve possible. Now there's obviously a constraint, the constraint being the fact that we have to pay part of our limited income to buy these goods. So the name for this is going to be called our budget constraint. And in the budget constraint, we're going to have two variables, or two objects here. And that's going to be our total income, and then the prices of the two products. Now, with that said then, as if I have my same space, but I have now here quantity of crest, quantity of sushi, I can have a total income that's then used to buy these two goods. What we're going to have here, right, like if I had a total income of $1,000 and the price of crest was $1, just to make life a little easy here, and the price of sushi was $10, then right, obviously the maximum amount of each good is going to reflect the intercepts of my budget constraint, which would mean that if I devoted all of my income to crest, then obviously that would be 1,000 over 1, which is 1,000. So that would be 1,000. Or if I devoted all my income to sushi at $10 a piece, I just made up that number, this price and this price. At $10 a piece, that would mean the max I could get is 100. Then basically we would also face a trade-off here. But now the trade-off is actually rather easy to see. Basically, it's 10 tubes of crest for every piece of sushi, right? Or tray of sushi, right? Because if sushi is $10 and crest is $1, basically I can buy 10 crests or 1 sushi, right? That's the trade-off. That's going to be the slope of this, what is called the budget constraint. And that's going to be the negative ratio of the price of the good on the x-axis over the price of the good on the y-axis. Okay, so anything now below this frontier, or below this constraint, I'm just going to clean up this, let me just erase some stuff here just to clean this up. Basically, I can afford anything below this, okay? And I cannot buy anything outside of this constraint, this budget constraint. We're going to presume here that you spend all of your income. There's no incentive to spend less than your income, like to be right here, because you're not going to be able to save your money in this kind of picture. Okay, now here's the goal. Or step 3 of this process. Same space, quantity of sushi, quantity of crest. Again, let's remember what we're trying to figure out here. We're trying to figure out how much sushi and crest to buy to be the happiest I can at the cheapest price. Well, what we would do here is we're going to have our then indifference curves. And I'm just going to draw 3 of them. We would know that there's many, many, many of them. Now, there'll probably only be one budget constraint because you're going to be given an income level and you're going to be given a set of prices. And I drew 4 possible points here. So basically what I've done here is I've put the budget constraint, which is this straight line, on the same space as the 3 different indifference curves. So the question would be 1, 2, 3, 4. Which point basically represents maximum utility for given spending levels? What we're going to see here is that at point 2, the ratio of the marginal utility to the price is equal for each product. Now, right, we can see clearly here that at point 1, 2, and 3, because they're all in the same budget constraint, I could use the same income and buy bundles 1, 2, and 3. Well, we can see from looking at this picture that I would prefer 2 over 3 and 1. We know that we would prefer 2 over 3 and 1 because 2 is on a higher indifference curve. Now 4 we know is not possible because that exists outside of our income capabilities. At 2, these ratios are equal. At 1, at point 1, what we're seeing here basically is at point 1, people are not consuming enough crust and they're consuming too much sushi, which would mean that if that's the case, that the marginal utility of crust over the price of crust must be greater than the marginal utility of sushi over the price of sushi. And if that's the case, what would I as a consumer do? Basically that would say is that at point 1, for every dollar I have to spend, I get more happiness per dollar spent on crust than I do on sushi. So what would I do? I'd buy more crust, right? Because I get more happiness per dollar spent. Now, as I buy more crust, as the quantity of crust rises, what do we know happens? That the marginal utility of crust falls. Now we're going to presume here that prices are not changing at all. The only things changing are marginal utilities. Marginal utilities are changing because of the law of diminishing marginal utility. As the quantity of crust is rising, marginal utility of crust is falling. Right? So that would mean that this is then falling. This, on the other hand, would have to be rising. And this would be rising because I'd be consuming less sushi. As I consume less sushi, the marginal utility rises. At 3, it's the exact opposite situation. At point 3, the marginal utility of sushi over the price of sushi is greater than the ratio of the marginal utility of crust to the price of crust. Which would mean, right, whenever it has something greater than it, you always consume the thing where it's greater than it. Because basically, again, that would mean that you get more utility per dollar spent. As I buy more sushi at point 3, right, then the marginal utility will fall. If I'm buying more sushi, that would mean I buy less crust. So as this is falling, this is rising. And they're adjusting until they're equal. our optimal point. We're going to use that to derive the demand curve, which we'll do in part 4 of this video.